Mirror, mirror on the paper. No, let's not even go there. We're going to be looking at mirror images and specifically the virtual image idea and seeing where that virtual image is will be proving or giving evidence, I should say, that the law of reflection holds and that the image, virtual image, is as far behind the mirror as the object is in front. Your directions tell you to draw a line L in the middle of your paper. Now I have this up here so that it's just about level with the camera in front. We'll be toggling between one of those cameras and the overhead camera so that you can get an idea of how this looks. So first of all, let's look at the overhead camera. And you see I have my mirror along line L. Now you might be looking, by the way, I didn't have a piece of wood, I had this tray. That's not straight. No, the tray is not straight, but the mirror is. Make sure the back of the mirror, that's where the silvered surface is along the line, not the front of the mirror. The mirror is like, an eighth of an inch thick, so you don't want to be doing that. The back of the mirror on the line and that it is straight. Okay, and I have a slightly different surface. Doesn't matter if you use a block of wood. My mirror is a little over maybe 1.5 inches square. Yours may be 4 or 5 inches long, 2 inches high. Doesn't matter as long as it can fit touching the line and everything like you see there. Okay, now from overhead, what I'm going to do is I'm going to put a pin. It says about 3 centimeters, so that's a little over an inch in the front of the mirror. Now let's see what that looks like from our camera. Now you can see the pin and the image of the pin. Okay, now what is the next step? It says to place another pin about 3 inches in front and 7 to 8 inches to the right of pin O. Now I did not label these because I have no other marks on my paper, so I will know where each one of these are. And that way I'm not trying to write up there and everything. You can go ahead and make your marks on the paper as it tells you to. So about 3 centimeters in front. Now it really doesn't matter which side, and about 7 to 8 to the right, and I'm going to push that pin in. Okay, now you can see this is in front of the other one over to the side. Now what I want to do is now you can see here's the object and then there's the image in the mirror. What I want to do is I want to get the green pin lined up with the image in the mirror, not the top of the pin, but the base of the pin. See how I'm getting the base to touch? I don't care about the top. This one might be a little crooked, but the base is what's important. So I have those lined up. Now I'm going to take a yellow pin and I'm going to put it so that it is in line. There we go. Okay, can you see how that, now let's look at the overhead. See how I put the yellow pin behind the green one. Probably could have had it a little bit further back. Behind the green one, and then when you look at the other camera, you can see how those three line up. You have the green one, the yellow one, and this is my object, and I want its image in the mirror, and these two to line up. So again, you have your object in the middle of the mirror in front. Go in front of the object, over to the side, put a pin. Put your eye and move it until you see the image of the object and that pin lined up, and put a pin in between that pin and the mirror. That's the lap. At that point, we just have to reproduce the same thing on the other side. So I'm going to take these two out because they have made their little holes. And I'm going to go on the other side, and I'm going to put this pin, and I'm going to try this and make it a different angle, different distance. I'm going to put it maybe a little further in front, and then I'll slide this mirror over because it's not quite long enough. I'm checking the back and making sure it's in place, and then getting that straight. Just checking both sides. Yes. Okay. Now, do the same thing. I want to get the image. You see, there's the object. Here's the green pin. Where's the image? It's not there yet, so I'm moving my eye. Well, I'm turning the paper because the camera can't move until these two line up. Okay, and then I'm going to put this pin there. Okay, at that point, we are done with exploring the image, and I will continue drawing the line. So I'll go ahead and we'll reset this up and come back and look at figuring out all of these under the second part dealing with the law of reflection. Okay, so I'm going to remove the mirror, and when we look on the overhead shot, you can see A and B on the left. There's object O in the middle, and C and D on the right. Now, what I'm going to do is place my ruler along A and B, and then I'm going to draw a line from A and B back to line L. Now I'm going to go into a broken line, dashed line at that point, and I'll explain why later. I'm differing slightly from what's in the book. Okay, I can take out pins A and B. They're done. Then I'm going to go over to C and D, and I will do the same thing. Draw the line. Okay, and that happened to cross right at the place where there's a break. So I'm going to extend that. Okay, and really I should have, well, I moved it, made that go a little bit further past. So that location right there, that is the virtual image behind the line. So I'm going to label that V. And actually I can also get rid of all these other points, the pins. Okay, because what was happening? I was sighting along A and B and looking at the image of the object. So that's where it was. In the mirror, it appeared to be. And that's why I've drawn that as a broken line behind the mirror, but a solid line up to the mirror. Now, the next thing it tells you to do is you want to go ahead and draw segments from O to where this line crosses line L. And then also from O to where AB, the other line, crosses line L. Now what I'm doing, I don't know if you can see the color or not, but I put that in green. Let's say the light hit the object. It's going towards the mirror, right? doing. Then it bounces off. And that's what we're looking at. That's why I kept that as a solid line, because this is what the light is really doing. Do-do-do-do, pew. Okay, and that's why I saw what looked like object O, the virtual image, back here and lined everything up. But there really isn't anything back here. That's why I've drawn that with a broken line. The next thing we need to do is we need to take a protractor and draw normals at these 2 points. Okay, now I have to put the center of the protractor right where O and the line from C and D meet, making sure I have it straight. And then I'm just going to put a little mark right there for our 90. Okay, and then I can draw the normal. And then we'll do the same thing over here where AB meets point O and make our other normal. Now remember, the green here is the incoming, the blue is the reflected. Incident, reflected to the normal. So I want that angle and that angle. Okay, we're going to label that. This is the incoming. So incident 1, that's the reflected. Reflected 1. And so now what I want to do is I want to measure the angle of incidence and reflection. Now I know this is the letters, I mean the numbers are backwards, but that's the only way because this line isn't long enough, so I have to use that on the short side. And so right here, for that angle, that's the incidence, I'm getting 35 degrees. Now I can flip it on this side and measure with these 2 long lines here. And I'm getting about 32 degrees. So 35 degrees, 32 degrees. To be honest, because I ended up with point B close to point A, I thought, I bet this one will be off a little bit. Let's see if we get any closer on the other side. Now these are not necessarily going to match from here to here. Unless you exactly measure your points, which I didn't, I would not expect them to match. So I'm coming up with, on the reflected, oh, I didn't even label, but that was 32 degrees. And this is my incident 2 and my reflected 2. Okay, and the reflected was 32 degrees. Let's see about the incident from O to my normal. That's about 33 degrees, so a little bit closer, 32 and 33, 32 and 35. Now, I just happened to get those numbers pretty close. What I usually do is I try to make sure on one side I'm a little bit closer to object O, the other side a little bit further. And then what you see is, 32 and 33, and then maybe over here, 38 and 39. And that helps to show that those two sets do not necessarily equal. Just each incident equals each reflected. So that is evidence of the law of reflection. What about the fact that the object is as far behind, appears to be, the image appears to be as far behind the mirror as the object is in front of the mirror? Well, to do that, I need to draw a line from the object to where the virtual image is, and then simply measure from the object to the mirror and the virtual image to the mirror. And we'll do our start with 1 so we don't have it cut off. And that looks like 3.7 centimeters. And then from here, looks like about 3.8 centimeters. So the object is, and these are the numbers you're going to come up with. You're not going to necessarily get everything to be equal. The object is almost exactly as much in front of the mirror as the virtual image appears to be behind the mirror. But it looks like it's behind. I know. What happens is let's look at this and see if we can help to explain. Here's the light coming off the object. It hits the mirror and it bounces off at this angle. Now your eye does not know that it hit. So it's reflected at the angle. It just follows that straight line back, just like I drew this line. And so your eye says, oh, it's not over here. The image, it's back here, and the same thing there. So where these two lines meet, that's where the virtual image appears to be. Now you can sit and tell your eye both eyes, all day, although it said, close one eye and sight it. All day long, that's a virtual image. It isn't back there. Doesn't matter. You live your life seeing light coming in and figuring where it comes from in a straight line. This, it's not an optical illusion. It's just the way it is. Plane mirror generates virtual image. Equal distant behind to the distance of the object in front. And the law of reflection holds with a plane mirror and with all mirrors.